Hello student, due to the demand of the student, I am uploading the two videos 4.2 and 4.3. First of all, I am uploading the video 4.2. In this video, there are the properties of the determinant. Now first of all, only first three properties are very important, which are used in the frequently. And the next properties are used to solve some examples. Therefore, in the explanation, I am using only the first two properties. That is, when the rows and columns are interchanged, the value of the determinant remains unchanged. Means it doesn't change its value. And the second property, if any two rows or any two columns of a determinant are identical, then the value of determinant is 0. These two properties are mainly focused in this exercise. Now we'll see all the examples I will explain, and I hope that you will understand all the problems very clearly. But there are some problems. Without evaluating, prove that for these problems, practice is necessary. That's why you make the practice more and more, different types of the examples. Now let us start exercise 4.2. Now we'll start the determinant. The properties of determinant. The first property, the value of determinant remains unchanged if its rows are turned into column and columns are turned into rows Now see this one example. The determinant 2, 1, minus 2. Always read the determinant in this fashion. That is, read always the rows. That is a 2, 1, minus 2, 2, 1, minus 3, 5, 4, minus 9. Means that the first row is changed to the first column. Second row will be second column. Third row will be the third column. Now evaluate this determinant. This is we learn in the first exercise 4.1 to evaluate this type of the determinant. That is a 2 in bracket, that is the minus 9 plus 12, minus 1, minus 19 plus 15, and the last element is minus 2 in bracket 8 minus 5. Therefore, 2 into 3 minus 1 in bracket minus 3 minus 2 into 3, and overall we are getting the value of that determinant is plus 3. Now see this next. Rows will become the column, that is a 2, 1, minus 2. Next is 2, 1, minus 3, 5, 4, minus 9. We change here, that is rows becomes a column, and solve this. Evaluate this determinant of the order 3 by 3. That is a 2 in bracket minus 9 plus 12, minus 2 in bracket minus 9 plus 8 plus 5 in bracket minus 3 plus 2. and that's why 2 into 3 minus 2 in bracket minus 1 plus 5 in bracket minus 1, and the value of that determinant is 2. Therefore, from 1 and 2, 3 is equals to 3, and hence the value of the determinant remain unchanged. Now we'll see the second example. First example, exercise 4.2, first example. Now see this, evaluate this determinant, that the D is equals to 1A B plus C, 1B C plus A, 1C C plus B. Now how this comes? This will come by using the number of the time practice. There is one more property of the determinant, that any two rows or the columns are identical, then the value of determinant is 0. Therefore, I added C2 plus C3, means what? In C2 you add C3. Therefore, it is written as C2 plus C3. Therefore, if you add C3 in C2, then you will get second column, that is A plus B plus C, A plus B plus C, A plus B plus C. And if we take A plus B plus C common from the second column, then you will get first column is 1, 1, 1, second column is 1, 1, 1, B plus C, third column C plus A plus B. Now, very important property of the determinant, if any two rows or the columns, here columns are identical, C1 and C2 is identical, and that's why the value of determinant is 0. Now we are using the property of determinant to show that the value of determinant is 0. This we'll understand if we do the more and more types of the example. Now C1 is equals to C2, and hence its value is 0. That is A plus B plus C into 0, that is equals to 0. Now next, D is equals to 0. Second, 2, 3, 4, 5, 6, 8, 6, 8, 9x and 12x. Now again, C. Let D is equals to the given determinant. If you take D is equals to, we'll write first of all, that is a 2, 5, 6x, 3, 6, 9x and 4, 8, 12x. Taking, now what is there? Now see the, that is the first 3 common from C2 and 4 common from C3. That is a 3 is common. Again there is one more. If we take that common, then C2 and C3 both are identical, and that's why the value of determinant is 0. That is, without evaluating the determinant, you can write the value of determinant by using the property. And also if you solve that determinant, the value will be so 0. Now the next determinant, that is a 2, 7, 65, 3, 8, 75, 5, 9, 86. Now see this, that is C3 minus 9 times C2 gives. Now you will say that, sir, how this comes? But you will get this idea by doing the number of the times, by observing the numbers, what is possible that can we make any two rows or the two columns identical? Therefore, we have C1 and C3 both are the identical, and that's why its value is 0. Now next, R1 plus R2 plus R3. I had taken that examples directly. You see the examples from the textbook. Now here we are adding R1 plus R2 plus R3. Means R2 and R3 are added in R1. Whatever the written in the first row or the column, the remaining elements are added in that particular row. Now here is R1 is first. Therefore, in R1 we are adding R2 and R3. Therefore, we get in R1 2x plus 2y plus 2z, again 2x plus 2y plus 2z and 2x plus 2y plus 2z. Taking 2 as a common from R1, then we get that is a 2, and the determinant is x plus y plus z, x plus y plus z, and x plus y plus z, and that's why we have z plus x, x plus y, y plus z, and last row y plus z, z plus x, and x plus y. Now we are evaluating with the help of the property. Now the next is R1 minus R3, R1 minus R3, then we'll get that is a x, y, z, z plus x, x plus y, y plus z, and again that is a third row y plus z, z plus x, x plus y. Now R3 minus R1, R3 minus R1, see this, again this is repeated here. R3 minus R1, therefore we are getting now next is by R2 minus R1 we get R2 minus R1, that is first row is x, y, z, second row is z, x, y, and third is y plus z, z plus x, and x plus y. Now R3 minus R2, and in this case we are getting RHS, and hence LHS is equals to RHS. That is a 2 times, I forget to write the 2 there. That is a 2 times that the given determinant. Now the next. Now using the property of determinant, show that the value of that determinant is 4ABC. I forget to write in the last step 2 multiplied by 2. Now see this LHS is equals to B plus C, C, B. And second row is C, C plus A, A. And third row is B, A plus B. Now C1 plus C2 plus C3. That is, in C1 we are adding C2 plus C3. That's why we are getting 2 times B plus C. That is, in first column 2 times C plus A, 2 times A plus B. And the remaining 2 columns are identical as it is. Now next, take 2 common from C1, that is a 2 in bracket B plus C, C, B, C plus A, C plus A plus B, A plus B. Therefore, again, C1 minus C2 plus C3, we get, that is, C1 minus C2 plus C3. Therefore, we are getting that is a 2 in bracket 0 minus A, and in column wise C, C plus A, B, A and A plus B. Now next is, that is C2 plus C1 and C3 plus C1, we get keep C1 as it is, which is 0 minus A, and C2, in C2 we are adding C1. Therefore, next is, by taking ABC common from first column, second column, third column respectively. That is, from C1 A is common, from C2 C is common, and from C3 B is common. Then you are getting, that is a 2 in bracket ACB in determinant 0, 1, 1, 0, minus 1, 1, 0 and minus 1, 0, 1. Now evaluate this determinant. That is, you will get, from the first there will be 0, from the second it is a plus 1, and from the last is also plus 1. That is, 1 plus 1 is 2. That is a 2 into 2 ABC. It makes 4 ABC. Which is RHS. Hence, LHS is equals to RHS. Therefore, A plus B, A, B, A plus C, C, B, C, B plus C is equals to 4 times A, B, C. Now the next is 1 log of x, log of y to the base x, log of z to the base x, log of x to the base y, 1 log of z to the base y. And now in this year there is no logarithmic chapter for you. Now see the rules of the logarithm. That is, log of m to the base n can be written as log of m upon log of n. Log of m to the base m is equals to 1 if m is positive, and not equal to 1. Therefore, you must know these minimum rules. If the time permits me, then I will also upload the video on log table, that is the rules of logarithm, which is required in the calculations of physics and chemistry. Now next is log of m to the base n is equals to log of m upon log of n. When there is no base, then it is treated as e. Now see this LHS is equals to 1 log of x, log of y to the base x, log of z to the base x, log of x to the base y, 1 second row, then log of z to the base y, and last row log of x to the base z, log of y to the base z, and the 1. Now see this 1 means what? The 1 means log of x to the base x. If these two numbers are equal, then the value of that log is 1. Therefore, next is log of y to the base x, log of z to the base x. Now next is log of x to the base y. In this row, everywhere the base is y. Therefore, 1 is treated as log of y to the base y because y term is not present there. Therefore, we are taking the log of y to the base y, and I am keeping the third row as it is. It is not required to again put in that form. Now see this y, it is not required. Now I am changing the base, that is a log of x upon log of x, log of y upon log of x, log of z upon log of x, and the second row is a log of x upon log of y, log of y upon log of y, log of z upon log of y. And the keep third row as it is, that is a log of x to the base z, log of y to the base z, and the 1. Therefore, from these take common terms, that is from the first row we are taking the 1 upon log of x as common from the R1, and from the second row we are taking 1 upon log of y as common from the R2. Now what's happening here? That is, we are writing 1 upon log of x into 1 upon log of y. Then therefore we are getting log of x, log of y, log of z, and second log of x, log of y, log of z, and last row is as it is, log of x to the base z, log of y to the base z, and 1. Now in this case, two rows are identical, therefore the value of determinant is 0. Therefore 1 upon log of x into 1 upon log of y into 0, and whole the answer is 0. The problem may think you the difficult because here the applications of the rules of the logarithm apply here. But in this year, that is, there is no log table chapter, but if time permits me, I will upload the log chapter because it is necessary for the calculations in physics and chemistry problems, and hence LHS is equals to RHS. Therefore 1 log of y to the base x, log of z to the base x, log of x to the base y, 1 log of z to the base y, and last is log of x to the base z, log of y to the base z, and the 1, that is equals to 0. Now solve the following equation. If you solve directly equation, then it will be the very long expression, directly multiplication. Besides that, we are applying the sum rules, that is, we'll apply the column operation and the rows operation. That is why R2 minus R1 and R3 minus R1. That is, R1 is constant, therefore write always that is the R1 as it is, because the half work will finish because R1 is not changing, therefore write it first of all. And what about the second? R2 minus R1. Therefore in second row you are getting 4, minus 7, 3, and the third row you are getting minus 3, minus 4 and 7. Now for the next operation, by C2 minus C1 and C3 minus C1. Therefore, you are getting, that is x plus 2, 4 minus 3, second row 4, minus 11, minus 1, and third row, that is a minus 3, minus 1 and 10, that's equals to 0. Now, this is the simplified form of the determinant. Now, you can evaluate this determinant. If we evaluate the determinant at the starting, whatever the given determinant, it will be the very biggest polynomial, biggest multiplication, and instead of, to avoid this, we apply here the rows and column operations. By using that, the determinant is, variables are minimized, and that's why this evaluation is a regular evaluation. That is x plus 2 in bracket minus 110 minus 1 minus 4 in bracket 40 minus 3 minus 3 in bracket minus 4 and minus 33 is equals to 0. At the same time, you also see the solved examples from the textbook, then you will get the more and more idea. Next is in x plus 2 in bracket minus 111 minus 4 into 37 minus 3 in bracket 37, and that's equals to 0. The solved examples are also useful, very useful. Now see this, the multiplication. That is, the last is x plus 2 into minus 111 minus 4 into 37 plus 3 into 37, and that's equals to 0. Therefore, x plus 2 into minus 111 minus 37 equals to 0. Therefore, x plus 2 into minus 111 is equals to 37, and that's why you are getting x plus 2 is equals to minus 37 upon 111. Now in the 10th standard, you have seen that is, it was very easy, and in 11th standard everything is difficult, but don't fear this, I am there now. I will explain all the steps very clearly, but you have to do the practice. Do the practice of all the solved examples, each and every sentences from the textbook, and then you will get the good marks in CET also. Now we'll see that is, therefore x is equals to minus 6 minus 1 upon 3, and that's why x is equals to minus 7 by 3. These examples, when you solve, high concentration is necessary for this. Now the next is second example. Now solve this, that is, in the first row x minus 1, x minus 2, and the second row is a 0, x minus 2, x minus 3, and third row is a 0, 0, x minus 3. Now again we will minimize the variables, that is by r1 minus r2. Therefore, we are getting in the first row x minus 1, 2, 1, and the remaining two rows are as it is. Therefore, write down that first, second and third row. Now next is r2 minus r3. That's why x minus 1 as it is, 2, 1. And the second row is changing now. It is subtracted by r3, and that's equals to, that is a x minus 1, 2, 1, 0, x minus 2, 0, 0, 0, x minus 3. And now evaluate. Now the places of x are minimized here. Now the total 9 numbers are there. Out of the 9 numbers, only the 3 in the 3 places x is present there. Therefore, I hope that our determinant will be the minimize here. And evaluate now this determinant. And the last two terms are 0, and that's why we are getting x minus 1, x minus 2, x minus 3 equals to 0. Directly we are getting the factors, lucky. Therefore, x minus 1 is equals to 0, x minus 2 is equals to 0, and x minus and therefore the value of x is equals to 1 or x is equals to 2 or x is equals to 3. Hence, x is equals to 1 or x is equals to 2 or x is equals to 3. This is the solution. Now next problem, question number 6. If 4 plus x, 4 minus x, 4 minus x, first row. Second row is a 4 minus x, 4 plus x, 4 minus x, and third row is 4 minus x, 4 minus x, 4 plus x equals to 0. Then find the value of x, that is equals to 0. Now see this determinant. Now this is very important problem. Now see this, what adjustment I had done here, that is R1 plus in bracket R2 plus R3 gives. That is we are getting the 12 minus x in the first row, 12 minus x and 12 minus x. Second row is a 12 minus x. Second row is a 4 minus x, 4 plus x and 4 minus x. Third row is a 4 minus x, 4 minus x and the 4 plus x. That is equals to 0. Now take the 12 minus x as a common from the first row. Then we are getting that is 1, 1, 1 in the first row. Second row is 4 minus x, 4 plus x and 4 minus x. And third row is 4 minus x, 4 minus x and 4 plus x, and that is equals to 0. By taking the 12 minus x as a common. Now next is, we will apply here one more operation, that is the C2 minus C1 and C3 minus C1. Therefore, we will get, that is a A12 and A13 element will be 0. A12 means 1 and A13 means again 1. Therefore, the first column is as it is, that is 1, 4 minus x, 4 minus x. In the second column 0, 2x and 0. And the third column is a 0, 0 and the 2x. That is equals to 0. Now, in this case, we will evaluate. This is very highly eliminated form of this determinant, that is 12 minus x, and evaluate this determinant. Now the next A12 and A13, these two are 0, therefore the remaining values are 0. Therefore 1 in bracket 4x square minus 0, that is equals to 0, and that's why 12 minus x into 4x square, that is equals to 0. Therefore 4 is not equals to 0. Therefore x square is equals to 0, means what, x is equals to 0. And the second value is that 12 minus x is equals to 0. Therefore x is equals to 12. And that's why x is equals to 0 or x is equals to 12. This is the solution of the given determinant form equation, that is x is equals to 0 or x is equals to 12. Now next is write, that is without expanding determinant. Show that. Again this type of the questions are also very tough. Now see this, how. Now see first of all the LHS, that is the first row is a 1, 3, 6, second row is a 6, 1, 4 and third row is a 3, 7, 12 plus 4 in next determinant is 2, 3, 3, 2, 1, 2, 1, 7, 6. Now by taking 2 common from C3 in the first determinant, therefore we will get, that is 1, 6, 3, 3, 1, 7 and here is 3, 2, 6 plus 4, 2, 3, 3, 2, 1, 2, 1, 7, 6. Now in this case, now see this. that is a 2 is multiplied with the first column, and then it becomes 2, 12, 6. Second column is 3, 1, 7, and third column is 3, 2, 6. And in this case here, multiplied by 4 to the again the first column, that is a 2 is multiplied C1 for the first determinant, and 4 is multiplied. That is the first column of the second determinant. Now in this case, C2 for the first determinant C2 and C3, and for the second determinant C2 and C3, these two are identical, and by using the property of again the determinant, if the two rows and or the two columns are identical, then the remaining row or column can be expressed the sum of the two terms. Now here the two columns are identical, therefore the first column is written as 2 plus 8, 12 plus 8, 6 plus 4, and that's why C2 and C3 are identical. If we add them, C2 and C3 are identical in the two determinant. Therefore, we will add them now. That is a 2 plus 8, that is a 10, 20, 10, 3, 1, 7, 3, 2, 6. Therefore, by interchanging rows and column, we get that is a 10, 20, 10, 3, 1, 7, 3, 2, 6. Therefore, by taking 10 as common, then we will get. Now this exercise as comparative is very tough, because we have to apply here the properties of determinant. By making the number of the time practice, you can solve the examples. Also the solved examples are important. Solved examples are also important, and by doing the practice you will get more and more understanding of this type of the examples. That is, using the property of determinant, evaluate, solve this type of examples. Now we'll see in the next video 4.3. Till then, goodbye. In this way, we have completed exercise 4.2. I hope that you have understood all the problems. If you are new for this channel, then subscribe it, like it, and share it with your needy friends. Now we'll see in the next video 4.3. Till then, goodbye.